In this lecture, we will discuss the expansion of tan and theta in powers of tan theta. Expansion of tan and theta in powers of tan theta. We know that tan and theta is equal to sine and theta by cos and theta. Okay? The series for sine and theta is mc1 cos of n minus 1 theta sine I sine theta minus mc3 cos of n minus 3 theta sine cube theta plus mc5 cos n minus 5 theta sine 5 theta divided by mc0 cos n theta. Series for cos and theta in powers of cos theta sin theta is this one, nc2 n minus 2 theta sin square theta plus nc4 cos of n minus 4 theta sin 4 theta. Now divide the numerator and denominator by cos n theta, cos to the power n theta, we will get nc naught cos n theta divided by cos n. This term can be written as cos n minus theta sin theta divided by cos n theta. Okay? This term we can write in this form n minus 1 sin theta by cos n minus 1 plus 1 theta minus 1 cancel out. We will get this step. So in the next stage we can write cos n minus 1 theta sin theta divided by cos n minus 1 theta cos theta. If we add the power, we will get this way. This cancel out. This is 10. So this is equal to nc1 tan theta minus nc3. Here, if I replace 1 by 3, this will be 3. This is 3. This is 3. There it is 3. It is 3. So this is 3. Cancel. This is 2. So this is 10 cube theta plus n 5. This now 5 divided by MC naught. This cancels out. This is true. Now it is true. So it is true. This is minus 2 plus 2. So this just cancel out. This is tan square theta. Tan square theta plus MC4. There again this 4. This is 4. This is 4. Okay. So this is tan 4 theta. Tan 4 theta. So this is true when n is both odd and even. Only difference come in the last term. Next, we are going to find out what will be the last term when n is odd and what will be the last term when n is even. We will write the last step as it is required in the subsequent stage. This is your NC1 tan theta minus NC3 tan cube theta plus MC5 tan 5 theta divided by MC naught minus MC2 tan square theta plus MC4 tan 4 theta whole. Now case 1, when n is even, let n equal to 2m where m is positive integer. Okay. Now the last term of the expansion, we know that sine n theta plus I sine theta cos n theta is equal to cos theta plus I sine theta to the power n. If we expand this by binomial expansion, we will get this. We will get this one. This is m. This is m minus 1 theta sine theta I sine theta. I sine theta and C2 minus 2 theta I sine theta and minus this is 2 more than minus 2 goes on. Power of cos will be decreases. I sine theta will be increases. The term before the last term will be this one. And last term will be this one. Cos theta is 0 and 3 power 0 is 1. So these two last term. Now we are going to check out what will be the last term. will write I extra, take 1 outside, then it will be I 2m minus 2. If I add the power, I will get this one. Okay, 2m minus 2 plus 1, that will give you the power 2m minus 2. So this can be written as I square m minus 1 and cos theta sine m minus 1. This is equal to I minus 1. I square is minus 1. M is n by 2. N by 2 minus 1 and cos theta sine n minus 1. Okay. Now we are going to find the last term. The last term. The last term when n is even. The last term in the numerator. Okay. In the numerator when n is even is, what will be the last term when n is even in the numerator? Is in the numerator is sine and theta. Sine and theta is the sine and theta plus this is I sine and theta. This is cos and theta is the imaginary part when we expand this by binomial expansion. Okay, this is imaginary. So to obtain this, we will write it here in the last term. That is minus 1 to the power n minus 1 by 2. Okay, and cos theta sine n minus 1 theta. To obtain this series, we have divided the numerator and denominator by cos n theta. Okay, cos n theta. I can write this in the next step minus 1 plus 1 theta. So this is minus 1 to the power m by 2 minus 1 and cos theta sine n minus 1 theta divided by cos n minus 1 theta cos theta. Okay, cos theta cancel out. This is equal to minus 1 to the power n by 2 minus 1 and tan n minus 1 theta. So when n is even, the last term is the last term in the numerator when n is even is minus 1 to the power n by 2 minus 1 and then n theta. Okay, this one. And the last term in the denominator when n is even is, what is the last term? Last term here it is cos and theta. That means we can last term here will be this one minus 1 to the power n by 2 then sine n. Okay, here the last term we have divide the numerator and denominator by cos and theta. So this is minus n by 2 and n is this one minus 1 to the n by 2 minus 1 n, then to the power n theta, and the last term, the denominator is minus 1 to the power n by 2, then n theta. Okay. Now case 2. Case 2, when n is odd. When n is odd, we will do this and take this n equal to 2m plus 1. There it will be 2m plus 1. From here, it will be changes. We will change this. That is I 2m I sine n. This can be written as I square m I sine n. This is minus 1 m from here. This n equal to 2m plus 1. This implies n minus 1 by 2 equal to n. Okay. So n minus 1 by 2 I sine n. Here when n is odd, this is the n cos theta I n minus 1 sine n minus 1 theta, and this is equal to n cos theta. This can be written as I 2 and m here, and I have taken this one to left hand side. This is n minus 1 equal to 2m, n minus 1 n minus 1 equal to 2m. Now this is sine n minus 1 theta. This is cos theta I square m sine n minus 1 theta. This is equal to n cos theta minus 1. Now from here we can obtain m equal to n minus 1 by 2 sine n minus 1 theta. Okay. So the last term in the numerator, when n is odd, is when n is odd, the last term in the numerator, that is sine n theta, that will be the imaginary part. Imaginary part is this one, minus 1 to the power n minus 1 by 2 sine n theta. We have divided the numerator and denominator by this. Last term in the numerator will be this one, minus 1 to the power n minus 1 by 2 then n theta. Okay, then n theta minus 1 to the power, and the last term in the denominator when n is odd is, what will be the last term? Let's check it. Plus, for last term cos n theta, that is, it is purely real part, can be obtained by real part. Okay, cos theta I am writing minus 1 into 4 sine n minus 1 theta. We have divided the numerator and denominator by this term. So this can be written as minus 1 plus 1 theta. So in the next step, it can be written as n minus 1 by 2 and cos theta sine n minus 1 by 2 to this power, okay, n minus 1 by 2 by 2 and then n minus 1. The last term in the numerator when n is 4 is this one minus 1 to the power n minus 1 by 2, 10 to the power n theta, and last